Okay, class, this is the correlation and line of best fit video. First thing we're going to talk about are types of correlations. A positive correlation means that as one set of data increases, the other set of data also increases. And what that looks like is, if you have a bunch of data points, it'll generally have a positive slope if you drew a line of best fit through there. You don't have to draw a line of best fit, I'm just saying. It should look like that. A negative is the other one, other way. So if one set of data increases, then the other set of data will decrease, or the other set of data decreases. And that looks something like this. No correlation means there's no pattern or relation. It doesn't do either of that. They don't really go together. And that kind of just looks like a scatter of dots somewhere, everywhere around the graph, where it's really hard to figure out a line of best fit through that. Alright, so those are all three of those. So we're going to first talk real quickly about what do you guys think is positive, negative, or none. So time spent running on a treadmill versus number of calories burned. So let's just pick one way. So if you spend more time running on a treadmill, you should also burn more calories. Since they're both increasing, this would be a positive correlation. If the temperature rises, it's getting hotter outside. So if it's getting hotter outside, the number of hot chocolates sold should go down, right? So that means that as one goes up, the other one goes down. This would be negative correlation. Number 3, number of home runs scored versus how many apples were picked. I cannot see how you can really relate those, so that would be no correlation. Okay, since there's 24 hours in a day and you're either at work or home generally, if the number of hours working goes up, the number of hours at home should go down because you're at work more. So this would also be another negative. They're in different directions. Correlation. And finally, time spent in direct sunlight. So if you're outside longer, the severity of a sunburn goes up. So you would agree that if you're outside longer, the time increases, the sunburn severity increases as well. So this would be a positive correlation. And then if you could always apply correlations to songs. For instance, Sir Mix-a-Lot's Baby Got Back. The first line is, I like big butts and I cannot lie. So we can make a graph, the enjoyment of big butts. If you really like that, then you cannot lie. The ability to lie is the Y. However, if you don't like, then you do have the ability to lie. So that would be the can lie. And this is the correlation. So you can have fun with different song lyrics based on what they say in them and the correlation between them. So that's just a fun little graphic about that song right there. Alright, a line of best fit. A line on a graph showing the general direction that a group of points seems to be headed, or heading. So this is where we're going to use our calculator. So pause the video now if you don't have your calculator out and go get your calculator. So hopefully you have your calculators now. I'm going to give you guys a list of data points. This is the number of US births from 2000 to 2007, and X starts at 0, so that's years since 2000. And you'll see that a lot. And Y is in thousands of births. Okay? Actually, it says draw a scatter plot of the data. So I'm going to just plot that by hand first, going from 0 to 7. So 0, 1, 2, 3, 4, 5, 6, and 7. And then I am going to start my Y-axis at 3800. I'm going to make the little break thing here first. And then I'll say this is 3800. Actually, that's technically in thousands too, so it's really 3,800,000. 3900. And with graphs, it's always good to label them. So this would be number of U.S. births from 2000 to 2007. Depending on when you're watching this video, you might be one of these births. I think we're getting close. Alright. Actually, no, I think some of you guys were born in 2000 or later. So, let's make the axes now. This is years since 2000. And then this over here on the side is number of births in thousands. Okay? So now you just do a plot. I'm going to just plot it because I have it on here, and it's hard for me to keep scrolling up and down. So at 0 we have 4158, so that's right here. I kind of made that axis weird actually. Usually I would put 0 over there, but yeah, just for this video we're going to do this because it's already... No, you know what, let me just fix that. Let me fix this axis. There we go. So at 0 we're at 4158. At 1 we're at 41.1, which is about right there. At 2 we're at 4065, which is about here. At 3 we're at 4,000, or 4 million actually. That's about there. 4 we're at 3950, so that's kind of in between. 5 we're at 3900, so that goes down to here. 6 we're at 3891. It's close to 3900, so that's about right there. And then 7 actually goes a little bit up. We finally had an increase in birth rates in 2007. Clearly you should see that this is generally a negative correlation. So our slope should be negative when we get our equation. This is how you do it in the calculator. You need to enter the data first. So when you get your calculator out, we don't need to be on this screen. You want to go to stat, which is the right below the delete key, 2 over from alpha. Stat. It's already on edit. The first button you hit, edit, you hit enter. And here are your lists. Now if you have stuff in your list, here's how you get rid of them. Do not use the delete key. Go up to the top where it says L1, hit clear, and then enter. Go up to the other list, L2, highlight it, clear, enter. You should have this, where you have no data in there. Now you can just enter the data. 0, enter, 1, enter, 2, 3, 4, 5, 6, 7. Enter. Move over and match up the numbers for each data point. So 4065, 4000, 3953, 39, 3891, and finally 3895. It should match. Hopefully don't type anything wrong in. That could be where your problem sometimes show up. So now we have all the data in. We can then hit stat again, but instead of edit we want to move over to calculate because we have our data. And I'm going to go down to linreg. This is the thing we want to do. We want a linear regression. Okay? And then this is what you guys are going to get. You're going to get a thing that says x list, y list. Our x list is y1, our y list is y2. And if you want to store your equation into y1, you can go to vars, which is right next to the clear button. Then move over to yvars and hit enter for function and hit enter again for y1. And so that's saying that I'm going to store whatever equation I get into y1. And then if you don't have to do that though, you can just go down to calculate and there is our equation. A is your slope, B is your y-intercept. So that's all we have to really write down, round to 3. So I'm going to write down that I got an equation of y is equal to negative 41.464 x plus 4141.75, and that is the equation. Again, what I did with that y1 thing, if you go to y equals now, notice how that exact equation is in there, and you can then graph it if you had a graph, but you'd have to change your window and all that. So we're not going to really worry about that right now. So I have that. There's my equation. So this is B. I'm approximating the line of best fit. You don't have to draw it. I just want the equation. And then C, I want to know in 2010. So when x is equal to 10, I get y is equal to negative 41.464 times 10 plus 4141.75. So I get that y is equal to 3727.11. Make sure you label it correctly. This is in thousands, so it's that 1,000 births. Okay. So we get the equation from our calculator and then just plug in for part C. So it's pretty basic. You just need to know how to do that, and I will go over that more in class as well. Finally, interpolation and extrapolation. It just is a definition stating that if you are interpolation, you are inside the data. So think inter, inside, extrap, outside, exit. So if I use that definition based on the problem right above it in part C, we estimated the number of births in the year 2010. Well, 2010 was not between 2000 and 2007. It is outside the data. So what we did up here was linear extrapolation. Okay? So that was what we did because 2010 is outside of the data. Okay, so that is linear line of best fit and correlation, linear correlation.